Hey everyone, today we're going to look at how to interpret, or otherwise known as how to read, a graph. Graphs are really useful tools when we're looking at a lot of information, and it's important to be able to read them and analyze and figure out what the data means. Uh, Graphs are really great because they help you learn patterns and trends and relationships between different things. You can look at a picture and look at a lot of information all at once. And compared to a data table where you're looking at lots of numbers and you have to kind of sit and figure out what each one means, graphs are really good at looking at lots of data all at one time. So, how do we read a graph? So we've kind of put together a how to, like where do you start? And the first thing that we want to do when we look at a graph is look at the title. The title is going to tell us what is this data about. That's really important. The second thing we're going to want to do is to look at the x and the y axis. The independent variable will always be found on the x-axis. That's what we're comparing. The dependent variable, what we're measuring for our results, will always show up on the y-axis. That's the vertical one. So x on the bottom, y on the top. And then third, we need to actually look at the data in the middle. So what do we see? Are things going up? Are they going down? Do you see some things that are the same, some things that are higher or lower? And so that's kind of the process that we want you to go through. So let's look. We know that all of our science information starts with observations. Let's look really quick. And you may notice as you go through that sometimes dogs, they love laser pointers. And so I'm not going to show you 3 minutes of that. If you want to look at the whole video, it will be available in the slideshow without the audio. So let's say we're interested and we want to know, and we want to look at some graphs that have come up with this topic, and we find this graph. We need to go through and break that down. There's a lot of information on this graph, and we want to use the skills that we're going through today to figure out what does this graph really mean. So where do we start? Again, start with the title. So the title tells us, does the color of the laser affect how fast my dog runs? So I know just from reading the title, I'm looking at different colors of lasers and I'm looking at how fast a dog is running. Step 2, we're going to look at the x and y axis. Let's start with the x-axis. On the bottom, we've got our independent variable, color of the laser, and I've listed purple, pink, blue, and green. So I know what 4 colors were being tested. No one seemed to test a yellow laser pointer. Maybe that's a future test we could do. But I need to know what is being compared. On the y-axis, I'm looking at average speed of dog, and it's in miles per hour. I wish it would have been kilometers per hour, but oh well, it's in miles per hour. That's what this person put their data in. And it looks like, obviously, obviously the smallest amount would be 0 miles per hour. Dog could just not move. And the fastest data point appears to be 20 miles per hour. That's really fast. All right. Step 3. Now we need to make observations based on the data. We're going to look, and this is a bar graph, so we're going to look at the bars. And the first observation that you should notice is that the tallest bar in the graph is green, which means apparently dogs run really fast after green laser pointers. We can also observe that the purple and the pink bars are the same. They both appear to cause dogs to run 9 miles per hour, or, oh, sorry, 10 miles an hour. And lastly, looks like dogs run the slowest when chasing a blue laser pointer. So, from our data, we should be able to draw some conclusions. What does this data mean? Well, green lasers cause dogs to run faster than the other colors in this test. Here we go. Let's look at another graph and see what we can learn. Now, before I go through step by step, take a moment and look at this and figure out, what is this graph really about? Again, step one, look at the title. Step two, look at the X and Y axis. What are the independent and dependent variables? Step three, then look at the graph and all of the lines and bars and look for patterns. So first we look at the title. Does the amount of time spent in quarantine affect the number of pets people own in Anoka County? All right, so I know that this graph has something to do with how many pets people own and how much time they are quarantined. And I'm looking through and I'm going, interesting. So what am I really comparing? Well, I look again on the x-axis. I'm comparing different months. Now, I maybe looked at the title and went, oh, maybe I'm going to be looking at different people. But now I'm actually looking at different periods of time, and things slowly changed over time. And because we have change over time, we're looking at a line graph. On the y-axis, we're looking at number of pets owned in the year 2020. And so people were getting new pets, maybe some pets ran away or something, and then people got more pets. So that's what I'm looking at here. And then lastly, now that I know what my graph is about, what am I comparing, what am I measuring, now I know I can look at the line and actually make sense of the data. So I observe in general that the pets have increased. We started back in January, we started at 1 pet, and over time it went up, a little down, back up, and now we're up to 5 pets. Can also observe, okay, the high point was October and November were tied, and that the low was at the very beginning in January and February. Another really great thing we can do when we look at a graph is we can get specific data points off of this. I can take this graph that's in front of us and I can find what was happening at every single month. Let's take a peek at how to do this. Let's say we wanted to know the number of pets owned in July. The first thing we need to do is look at the graph and find July. Now, we're comparing the different months. So I go down to the months because that's what I know. I'm looking for July. And I look across and I see right here is July. So I put a little arrow here. That's our first step. The next thing is to follow the line up until it hits our line that we've found in our graph. So I'm up here and I find this point. And once I've found this point, I'm going to go horizontally across. And I'm going to look for my data on the y-axis because that's my dependent variable. And it turns out that the number of pets that were owned in July is 4. We had 4. And then it looks like in the next month, if I want to do the same thing, I can go to August. I can go up. I can say, okay, here's where I hit the line. I can go straight across. And in August, we had 2. Let's try this with another graph. All right. So I want you to go through the 3 steps. What do we look for? Look at the title, look at the X and Y axis, and then look through all of the lines. It's it's a little bit overwhelming if we just start looking at the lines going, whoa, there's red and blue and there's all kinds of things going on. One thing to note when we have a double line graph like this, or whether we have multiple bars next to each other that are different colors, we want to look for the legend or the key, and the key is going to say what each of those lines mean. So here we're comparing different years, but we have a line for zebra mussels and a line for rotifers, and we can compare how those two relate with each other. And so when you see different colors, they should be represented with a key of some type. Really, let's look at one more graph. In this graph, we have a title on the top. Again, we're looking at on the independent variable and the dependent variable, and then we'll go through and look at our data. Um, be careful that you know what type of graph you should be using. Um, there's going to be some questions that pop up here, and so as you go through and answer those questions, um, use caution. If you have to put like a ruler up on the screen and like hold it up and okay, go straight across. Make sure you understand what that data means. And I know there's some big numbers on this one, but I think we can get it. All right. Good luck. Let me know if you have questions.